My name is Santiago Gael Jimenez Cantu, and I'm going to explain our PIA about our website that is called Digestive System. Digestive System is by team number 1, and our group is 202. Welcome to our final PIA website about the digestive system. This website was created by us, the team 1 from group 202. As part of Introduction to Robotics project, throughout this semester, we studied how the digestive system works, what organs compose it, and how health problems can affect its normal function. We connect this information with robotics with proposing a technological solution, a real digestive system problem. Our selected problem is gastroreal reflux disease, also known as GERD, or chloric acid reflux. GERD can be difficult to monitor because its symptoms may change every day, and many current methods are temporarily uncomfortable for patients. In this website, you will find research data, the main problems related to digestive system or project smart capsule composal, program evidence, journal explanation, conclusions, and team information. Our goal is to show how science, health, and robotics can work together to create useful solutions. The project helps us understand that robotics is not only about moving machines. It can also support medicine, diagnosis, and patient care. This is our digestive system image and the team members. Now we're going to go to research data. Research data of digestive system. The digestive system is a group of organs work together to break down food, absorb nutrients, and eliminate waste from the body. These systems provide the energy and materials essential for growth, repair, and normal body functions. It includes the mouth, pharynx, esophagus, stomach, small intestine, large intestine, rectum, and anus. It depends on accessory organs such as the saliva glands, liver, gallbladder, and pancreas, which help digestion by producing substances that support the chemical breakdown of food. The digestion begins in the mouth, where the food is chewed and mixed with saliva. The pharynx conducts the food to the esophagus, and the esophagus moves the bolus towards the stomach. The stomach secretes gastric acid to help break down the food. The liver helps with the detoxification and produces important substances for digestion. The pancreas secretes insulin, glucagon, and pancreatic juice. Finally, the rectums hold the feces before eliminations. The main organs we reviewed are the mouth, the esophagus, stomach, liver, and pancreas, and rectum. Now we're going to go to the problems. Health problems. Several disorders can affect the digestive system and make normal diffusion difficult. In our research, we identified the major disorders: gastro reflux disease, pyloric ulcers, irritable bowel system, and inflammatory bowel disease. Each one affects the digestive system in different ways. Some conditions are pain and discomfort, while the others cause chronic inflammation and or damage to the digestive organs. These problems show why it's important to study the digestive system and understand how they can support diagnosis and treatment. Our selected problem is gastric reflux or GERD, as we said in the previous slides. It's a chronic acid reflux condition that irritates the esophagus. It is a common, can be difficult to monitor because symptoms may vary from day to day. Current magnitudes can be massive or comfortable or temporality. Now we're going to explain how each of the health problems in the system work. GRD, as we explained before, is a chronic acid reflux that irritates the esophagus. Pelvic ulcers, sores in the stomach, linding or small intestine. Irritable bowel syndrome, abdominal pain, and bowel changes. Inflammatory bowel disease includes Crohn's disease and ulcerative colitis. this is the digestive system scenario we made. Now we're going to go to robotic solutions. Robotic solution. Our prototype solution is a robotic small capsule for acid reflux monitoring. The idea is a miniature robotic capsule that can be swallowed like a pill. According to the previous research, the capsule will contain pH in person sensors that transmit real-time data wirelessly, mood controlled or actually devices through a mobile application. This proposal is connected to GRT because the condition can be monitored over time when symptoms change. The doctor needs more information. The purpose of Smart Castle is not only to replace the medical treatment, instead it will support diagnosis and follow by giving doctors and patients more information. Our Tinkercard design represents the sternest shape of the proposed robotic device. The design includes a mass body and leg-like parts to represent movement and control. For real medical device, the movement will need to be safe, precise, and controlled from outside the body. As we can see, this is the prototype we made. These are the legs and the body. These will be the parts that show that send the data to the body. And this is a robot we use for the demonstration. And again, the digestive system model we used. Now we're gonna go to the programming we use. The program section so that program was controlled by us, Logic. Our program the blocks we used were DC motor FF, DC motor FB, and this DC motor 00. And we used commands such as delays and delays and off and on ports like the 1, 2, 3 ports. This action held the movements and signal different movements in the distant system journey. As we can see here, we have the flowchart that is have the start, the DC motor FF, delay 4 seconds, DC motor FF, FB, delay for 0.4 seconds, DC motor 00, and outputs with the loop and repeat. This is the screenshots from the robotic practice that we use the Logic system, as you can see here. And now we're gonna show the video of the demonstration. As you can see, the robot starts to move around the body, the body organs, and it starts to send signals to the mobile phone so that you can see what is happening in the body. Now we have another video of the Risi or another robot. As you can see, it starts to move. This one is we control it by ourselves by making the controller by using a controller. We didn't use we didn't use a Logic program. We used a controller program with Logic, but not with these blocks, with another blocks. Okay, now let's go to the journey. The journey explains how the robotic device will interact with the digestive system. In our program, the patient will swallow the device like a pill. The device will travel to the esophagus where it could measure the acidic levels and pressure. The information will be transmitted to a wireless in real time, and the patient could receive alerts or feedback through a mobile application. The journey steps are no, to control the device from inside the body, or research propose use magnets to guide it towards a specific organ or area where it is needed. The device will also require chemical sensors to detect different substances in the body. However, these are important challenges. The device must avoid blocking blood vessels, damaging tissue, or destroy the immune system. For physical demonstration, we use a real robot and and a digestive system dictionary to represent the movement and path to the proposed solution. The unit steps we use are the passage allows the robotic device, the device travels to the esophagus, sensors detect pH and pressure information, the data is transmitted wireless in a real time, the passage receives feedback through a mobile app. The feedback may help reduce acid reflux episodes. As we can see, the video we already showed. Okay, this will be all for today. I'm going to show you the team information that all we used for presentation was HTML website. The team members are Santiago Castillejos, Fatima Chapa, Daniela Raquel, Alexa Guillén, Santiago Jiménez, Dana Zamparilla, and that will be all for today. Thank you for your attention and see you the next time.